Hey everyone, in the previous few videos we've talked about arrays, and there's one major disadvantage with arrays is that they are a fixed size data structure. These fixed size data structures are also known as static data structures. Basically what it means is I can actually do something like int n, then do a scanf, and just take an integer from the user and then make an array with size n, and then run a loop for size n, and just take input from the user of that size. This is actually perfectly valid, but this doesn't change the fact that once I've committed that this array is of size n, I can't change that. So that's a major disadvantage with arrays, because sometimes things are constantly changing. We need to add things to a list, we need to remove things from a list, and it doesn't make sense to actually have an array of 1,000 elements and then just add 100 elements, then remove one from it, or add some 5 or 10 to it. Basically we're just occupying space for 100 integers. That's not 1,000 integers. That's not a good idea. So as a solution to this, we have a few functions built in C which we can use, and for that we just need to include another library which is the stdlibh.h. So remember to import this library when using these functions, and using these functions we can actually make dynamic arrays. And the first thing we need to do is we need to create an integer pointer, and let's just call this ARR because we are going to make this into an array kind of thing now. So once we've created this integer pointer, right now it doesn't contain any address to any integer. So what we want to do now is actually allocate some memory for this pointer to point at. Let's say I want 4 integers, so I want to allocate space for 4 integers. So that's something that we are going to do using a function called malloc, that stands for memory allocation, or we can also do it using a function called calloc, which stands for contiguous allocation. Malloc also just does contiguous allocation. It's just that these two functions have some differences which we'll talk about. But before that, there's something that I want to mention here. So let's just let's just try using this operator right here, which is the sizeof. So within sizeof I can give something like int, and let's see what this does. GCC dynamic arrays.c. I'll just leave this as a.exe again, and let's just hit A. So as you can see, it printed 4, and that's because integers in C occupy 4 bytes, and we can actually try writing float here, and let's just run this again, and as you can see it says 4 again because floats also occupy 4 bytes. Let's type in a double here, and let's compile once again, and this time it printed 8, and that's because doubles are actually double the size of floats. So doubles are 8 bytes in C, and if I say char here, this is going to give me a 1. That's because characters in C are 1 byte. So that's what the sizeof operator does, and this is important because we are going to be using it in our malloc function. So this malloc function takes a single argument, and that argument is the size of the memory block that it needs to allocate, and this time we want that to be 4 into 4 actually, because this is an integer, so it's going to occupy 4 bytes. But that's not usually how we write it in malloc. We just give it a size of and we write int here. So what this means is that allocate 4 blocks, each of size same as that of an int. So that's what it means. And let's just go ahead and do something like for int I equals 0, I less than n, actually I less than 4, I plus plus, and let's just do a scanf %d and ampersand. And the way to access these memory locations is I can actually just do it the same way that I do for an array. So I can just do ARR of I, and after this let's just do one thing. Let's just do an I equals 0 here, I less than 4, I plus plus, and within this I'm going to print two things. The first thing that I want to print is the address, and that's a %p. I'll give a comma and then I'll print value equals %d, and here I need to give it two values now. The first one is the address, so that's ARR of I, actually ampersand ARR of I, and the second that I need to give is ARR of I itself. So this is what I want to print out. Let's just clear this and run this now. It's actually waiting for me to give input, so let me just give 1, 2, 3 and 4. So actually it would have been better if I just add a \n here, and let's just do it again. 1, 2, 3 and 4. So as you can see, I got 4 addresses and 4 values, and these are ones that I had entered. So this malloc works just perfectly, and as you can see, these addresses are consecutive. They're called contiguous memory blocks. So these are all one next to one another, and let's just this time try not doing this, and we'll just print out the values. Let's see what happens here. I hit an A, and as you can see, it has given me totally random values. The reason for that is because when we use malloc, it doesn't set specific values for the memory that it allocates. So this actually is whatever values were in there for in these addresses for whatever reason. These are just some random garbage values. So another thing that I want to show you is calloc. So let's just do a calloc here, and calloc actually doesn't take a single argument, it takes 2 arguments. The first one is the size, the first one is the number of blocks that we want, and the second one is the size of each block. So let's just go ahead and run it now. Alright, I didn't save this file, and let's just run it now. And as you can see, it again gave me these 4 contiguous memory blocks, but this time all of them actually contain the value 0. And the reason for that is because other than the fact that calloc takes 2 arguments instead of 1, the other difference between malloc and calloc is that calloc actually initializes all of the memory blocks to contain a value 0. Malloc doesn't do that. And the entire reason we were talking about this is because we wanted to actually make these arrays kind of dynamic, and the way we can actually do that is using a function called reallocate, so it is actually realloc. So let's just go ahead and try that function, and this takes again 2 arguments. The first one is the name of the pointer that we want to reallocate memory to, and the second one is the size that we want, the new size. And let's just say sizeof int. So let's just try this now. It's just a warning which says that we are ignoring the return value of realloc. So I can actually run this. We are not printing out anything or waiting for any user input, but this works fine. And what this is going to do is it's now going to allocate 8 bytes to this ARR instead of just 4, and we can then access ARR of 5 or ARR of 6, and it'll be safe to access these because these have been allocated by realloc. So it's not like when we use arrays, because even in that case, because C doesn't perform bound checking, we can access those values, but that's not actually a safe thing to do. But in this case it's perfectly safe. And all of these malloc, calloc, realloc, in case they don't find enough space to actually allocate, they also sometimes just return a null value. And otherwise the return type of malloc or calloc is the address of the starting block of the memory that they have allocated. So if I actually just try doing something like this, let's do a %p here, a \n, and calloc of this, and a parenthesis here. So let's just go ahead and try that out, and as you can see it printed out an address, and that's the address of the memory block, the starting of the memory block that calloc has allocated. So those are the functions that I wanted to talk about. And one last function is the free function. The free function is actually very important so that we are not wasting memory. So the free function actually just removes all the memory that was allocated to this ARR. So by removes I mean it frees that memory, so that memory is now free for other things. So as you can see, I didn't get an error here with this free function. So that's what I wanted to talk about in this video, and I think that takes care of talking about arrays. And there's actually a special kind of array that we're going to talk in the next section, and those are character arrays. They're also called strings, and we'll talk about those in the next section. So I'll see you there.